Hello everyone, welcome back to Exquisite Tutorial. In today's video, we are going to be talking about TVD vector analysis. Okay, we are going to be starting from the beginning and talking about the introduction. Now on the board, we are having two diagrams. We are having two cubes. Okay, although they are not drawn to scale, but you should know that they are both cubes. Now, still on engineering mechanics, let's say we are having this diagram like this. We call here the z-axis, we call here the x-axis, and we call here the y-axis. It doesn't matter if I should call here the x, the y, and the z, provided that the components are all perpendicular to each other. Now, let's say we are having a vector like this, okay? A vector, and it's having an angle to the x-axis, which I'll call alpha, an angle to the y-axis, which I'll call beta, and an angle to the z-axis, which I'll call gamma. Now, to resolve this vector, it is very simple. What we have to do is resolve to the x-axis to get the x component. So we are going to have f of x to equal, if the vector is a force, let's say a force f of x is equal to f cosine of alpha. Of course, we are using cosine of alpha because we are closing the angle. Now, to get f of y becomes f cosine of beta. Okay, cosine of beta means we're closing the angle like this, so we are going to make use of what? Down cosine. Now, to get f of gamma, we simply resolve to the z-axis. Therefore, it becomes f cosine of gamma. Now, come to this other diagram. If we're having a diagram like this, let's say in this case, the vector is drawn from one edge of the cube to the top corner. Okay, so we're having a diagonal line. So it's drawn like this. This is a TVD vector, and this is also a force F. Now, if we want to resolve this force to the plane, it means we are going to be having a component that is shown like this at the bottom. Okay, if we resolve it to this bottom such that this force lies on this plane. Now, let's say the angle we are having here is alpha, and the angle we are having here is beta. Okay, I'm going to call this the z-axis, call here the y-axis, and call here the x. Remember, I said we could call any of these angles any of this component the x, the y, or the z-axis. Okay, but just in this particular diagram, I'm going to make use of this vertical component as the z-axis and the other two as the x and y-axis. Doesn't matter, or I can choose to replace this one as alpha, beta, x, and then I'll call a y, just because for the other diagram we call this part the x and this part the y-axis. Now, to find the resultant component of this force, I'm going to call it gamma. Okay, we're going to call this part gamma. Now, to find the resultant, I'll first of all resolve this force F to this plane. Okay, once I resolve it to this plane, I'm going to be getting what I will call the F prime. Now, I'll call F prime the force I get when I resolve this diagonal force down to this bottom plane. So when I resolve it, I'm going to get F sine of gamma, because I'm opening the z-axis. Okay, now after resolving, we're not going to be having f prime on this bottom axis. Okay, and from then we can now get f of y. Now, to get f of y, we resolve f prime down to the y-axis. That will give us f prime cosine of beta. Okay, or I could make use of f prime sine of alpha. Now, f prime is f sine of gamma, so I can rewrite this equation as f sine of gamma cosine of beta, or it could be written as f sine of gamma sine of alpha. Now, how about the x-axis? To get the one for the x-axis, we are going to do the same thing. So f of x will be equal to get f of x, we resolve f prime to the x-axis. That will give us f prime cosine of alpha, or we could write it as f prime sine of beta. Now, again, f prime remains f sine of gamma. That will give us f of x to equal f sine of gamma cosine of alpha, and that will equal f sine of gamma sine of beta. Now, this is how we resolve forces in TVD. Now, what's the difference between these two? For this first case, the force is not intersecting with the edge of the cube. That is, it is having an angle directly to the x, the y, and the z-axis. But in this case, it is not having an angle to the x, the y, or the z-axis. After resolving it to the bottom, we notice that there was an angle alpha and beta to the x and the y-axis respectively. Okay, now those angles will then be used to resolve to get the f of y and the f of x and also the f of z components. Now to find the resultant force of these three, of course we can see that these ones are the Cartesian form. Okay, we're having the one for z. Okay, the one for z, f of z will simply be equal to resolving this guy to the plane. That will give us f cosine of gamma. Okay, that's for f of z. Now to get the net force, I'm going to call the net force Fr. So Fr will be equal to the square root of the square on the sum of each of these. So that will equal square root of f of x squared plus f of z squared plus f of y squared. Okay, this is how we solve for it. Now in our next video, we'll be taking some questions on this 3D vector analysis and how we can apply the various theorems to these vectors. Okay, see you in the next video.